Okay, hello guys. Welcome back to the machine learning training. My name is Dos Kandamali. As you know, for now, I'm your instructor in machine learning as far as the YES lab is concerned. Now, if you're just watching this video, this is a series of a machine learning in agriculture tutorial where I've started from the beginning, giving you the basics of so many things. So if you haven't watched my previous videos, I would recommend that you go back and watch the step-by-step procedures doing so many things in machine learning, okay? All right, so in this specific video tutorial, today we're going to see the classification problem, all right? So we're going to break down, first of all, what is a classification problem? And we're going to break down the procedures and the steps on how you tackle your first classification problem, okay? Now, I have a similar video, but in the first video, it was showing something like, the overview of how a classification problem looks like. And we did discuss something on the iris dataset. As you know, the iris dataset, of which in our case, we use the iris dataset that is actually built in the scikit-learn library using the load iris datasets. It's already pre-processed, as I told you, okay? So it doesn't have many errors. You don't see like null values, missing values, duplications, and so much. The features are already correlated and so much. So it's easy to get a high accuracy or precision recall or any other metrics that you might use. But I told you that when you're encountering your first, or as more as you building the foundation, of solving machine learning problems, you'll see that you encounter different kind of data sets. And these data sets can be a little bit noisy, you see? And if they're noisy, they can be dirty. So it means there are some procedures and the steps that you have to follow in order to build very accurate models, okay? All right, so first of all, what is classification problem? If you just go back to the scikit-learn website, this one here, the scikit-learn website, this is a very useful repository. It has documentation for so many libraries. And I recommend that if you're going to dive into machine learning, this should be your friend, your close friend, because it is very informative. So if you come here, you see the classification. As I said, machine learning problems can be classified into 2 or 3 different. So it can be classification, regression, and clustering, okay? So the classification problem, it is based on actually identifying which category a specific item or objects belong to, you see? So some of its applications can be spam detection systems. For instance, you have an email, you want to specify whether this email is a spam or it's not a spam or it's a legitimate email. So that is actually what we call a classification problem, okay? You're going to classify a specific category belonging, a specific item belonging to a specific category, okay? So we won't cover so much on how this one works, just the overview, but we're going to dive just writing into the coding part where you see how you first tackle your problems. All right, thank you. So now, there are some various steps that you have to go through, when you're training machine learning classification models, okay? So the first thing is you have to collect the necessary tools. So I believe at this particular moment, you already have the environment like this one. So I want to cover how to install the environment. So here I'm using the Jupyter Hub. You see, there are so many different but related tools that you can use. For example, you can use Google Colab. You can use a Jupyter Notebook, which is similar to this one. It's almost the same thing. Okay, so for now, I've already installed the Jupyter Hub and so many other tools inside it. Now, explaining how to install these tools is beyond the scope of this video. All right, so now, the necessary tools, this means the libraries. So here you can see I have imported so many different library files here. All these are the libraries, the tools that I actually need with this specific problem, okay? And the second part is the data analysis. And in my opinion, this is the most important part, because if you get this wrong, it will be very hard for you to find or create strong models that are very accurate, okay? So data analysis, actually here you have to understand the meaning and the predictive power of the variables. So you'll see the variables, what we mean by the variables. It is something you're going to see later on. So the data analysis is the very important part. Okay, then you have what we call feature engineering. And this to me is, okay, for me, feature engineering is sort of part of the data analysis because all of them are very, very important. Another very important feature engineering is there are some features that are maybe not correlated. There are some features, maybe they have some problems. So here, this is the part where you have to fix them, okay? So create meaningful features from the data that you have. And you have the pre-processing part. The pre-processing part, one can argue that this is all like the same block, like the data analysis, the feature engineering, the pre-processing, the feature selection. All of them are like, it's the same big procedure that has been broken down, but all of it is just meant to give you meaningful models at the end of the day. All right. Okay. So you have feature selections. I said you just keep the relevant features or the most relevant features, and the model design. That's where you're going to model your data. I mean, you're going to model your machine learning model, and then you're going to put in the important data inside. Then you see what we do, the hyperparameter tuning. Then you're going to validate and test. That is very, very important. And then at the end of the day, you're going to have to evaluate your model. Like you have metrics. So the metrics that you're going to use depends on the kind of problem that you're going to have. Okay. So for classification problems, we know that the metrics are the same. You have the what we call the confusion matrix. The confusion matrix gives you the accuracy, you have the precision, you have the recall, you have the F1 score, yeah, and others of the same considerations, okay? So, and then finally, you're going to conclude evaluating your model, okay, by checking whether you have, the best possible predictions or not. And if not, then you go back probably to data analysis, and then you read the data again, you go to the feature engineering, you add or you remove features, and so much of the like. So one thing you should always remember is when you're dealing with your machine learning problems, the first thing you should always remember is there is no one way that works like for everyone, you see? Because at the end of the day, it depends on how you think and how you look, your data looks like, and how you analyze your data, how you draw conclusions from the data analysis, and how you're going to approach it. So if you're going to follow these steps, I believe they can put you in a very good position from now onwards on how to deal with your data sets in the problems that you're going to be encountering. Okay, so today's problem is going to be Titanic passengers classification. This is a very common data set. I have seen it in cargo. I think, okay, cargo, if you don't know cargo, just come here. Okay, cargo. Cargo, in my opinion, is one of the very useful platforms as far as machine learning and data science is concerned. So if you want to learn more about data sets, about machine learning models, about data science, Cargo is a very useful place for you. It has to be your friend. So usually Cargo puts in different kind of challenges, and then people from across the world, they try to contribute. Some have rewarded, some are just there for you to understand. So all in all, it's a very useful, place where you can find your data sets and find the problems and building models. So Cargo. Naam sana. Mara jambo. Umekuta Zamda? Na wazimu, umekuta Zamda sana. Niambie. Unaumwa? Unataka kufa? Unakaribia kufa? Unaumwa nini? Unaumwa nini? Uko wapi? Basi ukitoka utaniambia. Pole. Nani? So this Titanic actually datasets and this problem was posted in the cargo website. If you just come here, you see this Titanic here, machine learning from disaster. So this was it was posted several years ago. I just found it. I thought it's very useful, and I thought it's just use it. Now, the first thing is from here you will have the instructions, the overview, the descriptions of the data, and so many. All right. So the Titanic datasets, it contains these variables. So the first thing you see the variables here. Here are the variables. So in your data analysis, you have to understand the variables. What are they and what do they contain? So for instance, you have the variable called survival. This is what we call the target variable or the label. So the target variables or the label is different from the rest of the variables. Okay. Now this tells you that whether, an individual from the passengers list in the Titanic, they survived or not. Okay. And the aim here is to check is to classify, is to train your model so that it can classify and predict whether a specific passenger in a Titanic, ship they survived or they didn't survive. So you'll have so many, because they have collected a lot of information. This is called, so this information, as you can see here, you have the variable called the class. So this is your ticket class, like whether you belong in the first class or the middle class or the third class, okay, which is the lower class. The sex of the individuals, you have the ages, you have this variable here, it's called the siblings, the part. So there are so many different information. We'll see them in our code later, in our programming part. And then the aim is to check whether or not these guys survived or they didn't survive. Okay, so it tells you so much information about it. If you're just interested, you can come and see more here. Again, the summary says that you have 891 unique values. These are like the whole number of, observations in our data sets. And then you have the passenger IDs, this whole passenger IDs, and you have the people who survived. So like out of all these 891 passengers, you have a histogram here, or a bar graph, where you see the number of survivors, which is 1 against the number of non-survivors. So the number of non-survivors exceeds almost by half, I'll say approximately, according to our data sets, while the number of non-survivors, the survivors is a little bit lower. And then you have the classes here, so you can see the number of people who are in the first class and the lower class, the middle class and the lower class. So there are so many. This is just an overview of our data sets, and we'll see more in our data when you're dealing with the coding. Okay, so let's jump back into our coding part and see. Here we have loaded the necessary libraries. I believe at this particular moment, if you have already been following my videos, then you'll see it shouldn't be a problem for you to see the different kinds of the data sets. The tools that we have. So for data analysis, I'll use the NumPy and pandas. We have shown a video series about pandas. Please, if you haven't watched it, I'd recommend that you go back and watch it. It's very useful. And then for data visualization, you have these guys for plotting your graphs, and you have the machine learning classifiers or the algorithms, which are so many. It depends on what you want to use and which one gives you the best or accurate results. Okay, so I won't go deep into one of these or any of these. I'll just show you, and then you have the metrics. So I have kind of broken down, the tools that you need, for data analysis, for visualization, for model building or classification, and then you have evaluation matrix, where you have the accuracy, precision, and the rest, as you can see there. Correct. So in the reading data sets, the first part is you're going to read your data sets. Now you can see here, this tells you that I have a training.csv and a testing.csv. So I have two files, and the first one is going to be for training, while the second one is going to be my testing data sets. Okay, I'm reading that. Oh, sorry, I have an unstable internet connection. So I'll just reload it. Reload the server. Okay, this is fine. Now, the second part is this testing.csv. Okay, the first part is train.csv. So if I come here and I run this, okay, first I have to run this block first here, the cell, and then I come here and run this one as well. Okay, this tells you that it's okay. Now I can see the data, the shape of my data, here. Okay, so before doing all that, I think I should just clear all the outputs. Just like this. And then if I come here and run this cell, you see the output, because I've already created this. Okay, it actually took me almost a week, and probably a little bit of a week to create this, because it's a huge program, and plus it needs a lot of information. So just putting this together took me a lot of time. That's why it's not easy for me to program it on the fly here, because it will take me so much. And since I've already done it, so I think it's already, it's good if I just share it what I did. Okay, so here, if you see that, if you want to see this, the shape of the training data, just 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 print the shape, train data to shape. This gives you the shape, the number of rows and columns. It says you have 891 rows with 12 columns. This is my training data sets. And I might want to do that with the test data so that I can see I have like 418 rows or observations, and then you have 11 columns. So the difference here between these two is because you have one less column in your test data. And this makes sense because in my test data, this specific test data doesn't have the target value. I mean, the target variable, simply because it was a competition. So usually in competitions, they give you test data that doesn't have the values. And then when you run it, you just give your predictions, and on the background, they just put the value. They have the labels where they see the results. Okay. So now the training data here, .head. If I say .head, it means by default, I need to print the first 5 observations. So if I just put maybe 10 here, it means I need the first 10 observations of my training data. That's why I print in training data.head. Okay, this is what you get. So this gives you an overview, because it is a data analysis part. As I said, you're going to analyze your data. So you see how it looks like, what variables are contained, and what variables may help you towards your prediction. All right. If you count here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 columns. This is exactly what you found here. You remember here when you print the shape. So it shows like your shape, it has this number of columns and then 881 rows. At this here, I'm displaying the first 10 rows, but if I go on, explore this file more, I'll see 881 records. So the first record here, for instance, you have the passenger ID. Okay, so the passenger ID, as we say, this is just an ID, a random ID for passenger, okay? And it's not very relevant when you're trying to build your classification model, because knowing the passenger ID in this particular instance, it doesn't help into knowing whether the chance of survival are higher or not, okay? Now you have survived. This variable is what we call a target variable or a label. A label says 0 if the person didn't survive, and if he was lucky to survive, then a label will say 1. So here you have zeros and ones only. This is the passengers class. You have 3 classes. So the first class is, as I said, we have already seen, the first class is probably for the rich, and then you have the middle class and they have the lower class, okay? And then the name here, the sex, you have age, you have, so this SIBS here is for siblings and spouses, okay? For siblings and spouses. And this part is for parents and children. So for this specific guy, let's say Mr. Owen Harris. Mr. Owen Harris is a male with 22 years old. And then he had siblings or a spouse, either one of those. One, like who was aboard, like in that ship, there was one sibling probably, or a spouse, because sibling and spouse are collected in one category here. So if he had 2, then we'll be having 2 here. He didn't go with a parent, okay, or at least a guardian that is acknowledged as far as this ship is concerned. And then this was his ticket number, okay. Then you have the fare, and then the cabin. So the cabin, this is like a section where he was where he boarded. And if you see a none, this stands for a null value, because it does not exist, because it's not specified whether they were in a specific cabin number, okay. Then you have embarked. So embarked, this is the port of embarkation. Like in this ship, there were 3 different ports: the S, the C, and the Q. I'm saying this because I've explored this data already. So I know. Now, so these are different ports of, place of port embarkation. Okay, so this goes for the rest of the data sets. You can just go in and visualize, see how it looks. And test data, this will look different, a little bit different, I'll say. As you know, it is 11, it has 11 columns. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? So this one had 10, this one had 12, the training had 12, the test only has 11. And why does it have 11? It is missing the survived part. And why is it missing the survived part? Now, the way the classification problem works is like this. Now, you are going to train your model using these training data sets. And then you're going to use the testing data sets to test your model and validate. So this means that our aim here, our job here, our objective that we have is to check for this data, for instance, in a testing set, Mr. Kelly, Mr. James Kelly, who is a male with these particulars, whether they survived or not. So they don't give us the answer whether they survived or not. You see, they just want us to train this model here. And when we are going to give this model, our model that we have trained already, a new value from any random value from here, it should be able to classify whether it is a yes or a no. But again, remember, the answers for this are already known somewhere there. So if you provide the answers, this is what we call the predicted answer. If you predict, say I predict this is a 0, you see, so somewhere beyond there, when you're submitting this model, they already have the testing values, they already have the testing labels, so they compare and see the accuracy. So how many did you get right against how many did not get right? Okay, so that is the whole idea of classification. So usually in the classification, you need to also have labels here, but the reasons they did put label in here is because you are submitting it to their platform, the cargo platform, and then basing on your predictions, they will have the data that is labeled, and then they'll compare, so they'll see the results. Okay, that is probably the short answer you can have. So for us here, we might probably just train it using our training model, and because they have answers here, we might want to use the same, so we can see how well we can predict. Okay, now now let's go to the exploratory data analysis, EDA. Now, EDA part is very, very useful because this helps you to explore your data a little bit more and then express them in terms of graphics, because this is where you can visualize in terms of charts, graphs, and so forth. Okay, all right. So if you print by this line, I'm saying print the training data.info. If I'm displaying the training data.info, it means I need to see the information about my training data. Okay, if I just print it here, I have so many information. Now, these informations here, these are the ones that I was explaining here. Okay, let me explain a little bit more. All right, so it gives you the summary. Okay, so my training data is a pandas data frame. Okay, if you come here, I was reading it as a PD, and we know that PD is a panda here. Okay, because pandas is important as PD. So whenever I'm referring to panda, I will use PD. Okay. So here I say, it just says, so this is the pandas data frame. It just tells the type of the object that trained data is. So training data, this here is a pandas data frame. And I could have used any name. So here I've said training data. Yes. And I say training data here, it's because I called my data and store in this training data variable. I could have used any other variable name of my choice. And for as long as I just wanted this to be a training data, it just has to be training data. Okay. Now the range, it says you have a total of 891 entries. This is exactly the same thing that you have seen in our previous, when I showed you in the cargo data sets. Here in the cargo data sets, I won't go back there. And then it shows in the cargo data set that you have 881 entries, which the index starts from 0 to 890. All right. So how many columns you have? You have a total of 12 columns, which I've shown you there. And then these are the columns. Okay, so you have column passenger ID, survived, the P class, all the way to the embarked. Okay, now here you see um, the tape, you see the non-null counts. So the non-null counts, this counts a number of null values in the column. So let me just show you real quick. If you come here in the passenger ID, if I don't have a value, if I miss a value, say here, that's a null, it's a null value. So it will count how many null values that you have and how many non-values that you have, okay? So for instance, you can see, you can spot some null values here. In the first 10 observations, you can see in the cabin part, you have this null value, you have this null value, you have finite null value, you have those null values, okay? So an overview of the data sets will come here and say, okay, hey, you have no null value because you have a total of 891 entries, and you have 801 non-null values. It means all the values are filled. But in the case of age, you see you have a couple of null values. Okay, if you take the total number of values like 891 minus this one, you get more than 100 null values. Okay, missing values. All right. So this goes on to tell you that you also have null values in the cabin and the embarked. Okay. Now the data types of your data sets. So the data types of your data sets, like the passenger ID, this is an integer. The name is an object. The sex is an object. You have the siblings is an integer, and so forth. So this tells you have different data types. This is important when you know. So the summary tells you that you have how many floats? You have 2 floats data types, which is in this case, fair and what? And age, right? Yeah, and age. Because especially for lower ages, you can see we have number of months, so it will convert it to some kind of lower, float numbers. Even for the rest, you have like 22.0. Yeah, so that's the age. And you have 5 integers and 5 objects, okay? Now this, the memory used, you actually don't care about this one. Now this is an overview of your data. Now, the point to note here is when you're checking the info of your data, go and analyze a portion of your data like this, and then you see, trying to find the relationship between here and here. This will give you an inside understanding of how your data really is. Now, the summary here is, I just said, is the total number of observations. You have 11 features plus 1 target variable, which adds to 12. And then these are the floating, two floating data types, 5 integers and 5 objects. Then the description of your data sets. Description of your data sets is something that you have to go a little bit further. So after you have seen the info, the overview, the layout, you're going to go a little bit deeper in the description part, where you have the passenger ID. As I said, I already said this before. No, I won't go back repeating this. I said, especially for these siblings, you have the number of siblings that are aboard the Titanic. You have the number of patch. Where did I find this? It's because of the cargo. I just went to the cargo data sets. The Titanic, they showed the overview, so I just read it from there. You can go back here anytime that you want, and then you see some more descriptions about the data here, right? That's good. So now, okay, let's see the description of the data. Now, the first one, we see the training data.info. Now we're going to write the code for training data to describe. You see the difference? This is .describe. It says in the column passenger ID, you have 891 observations, okay? And in the survived, you have 891 observations. It means you have a total of all values. There are no missing values. This is the first place where you can get to see if you have missing values or not, okay? Like in the age, you see you are a bit short here, so you have some missing values. Some of them are missing. Okay, so this usually describes mostly the numerical part, okay? So the numerical columns are described here. If it's not numerical, it's probably not going to be displayed here, okay? So what's the mean? Because you cannot find the mean, the standard deviation, the minimum value, and so forth. So the description part will go with the minimum values. I mean, the numerical values, and ignore some other, text values. Okay, so this is the mean. This is standard deviation of the passenger ID. Yes, you have the maximum, minimum. Yeah, the 25%, 50%, 75%, it shows you. So go study the description part, very good, and see, okay, so this was the total number. So if you come here, what this doing is it comes here, like for the passenger ID, it finds the total number here, like how many observations are there, and then find these, the mean, find the minimum value, find the maximum value, and that's something like that, okay? So for instance, from here, what can we learn? We can learn that, let's see something here. So the mean age, for instance, the mean age of the people who aboard Titanic, as far as this data set is concerned, was around 29 years of age, okay? And then the minimum age was around 4 months. This tells you that, right? And the maximum age is 80 years, okay? So the same applies to the rest of the data set. You can find the minimum fare, you can find the minimum everything, minimum, maximum, the mean, and the standard deviations. So what are the few observations? What did we observe so far? What are the few talking points? After seeing our data at this particular moment, we know we have to deal with the missing values, because we have missing values, and we have missing values in 3 different kind of columns. You have missing values in the edge here, you have missing value in the carbon, and you also have missing value in the what? Okay, I've seen it there in the edge, in the carbon, as well as in the port of embarkment. Okay, so these missing values, if they are not dealt, if they are not taken care with, then we have to, they can bring, inaccurate models. So we have to make sure that we sort this out. There are ways to do that. I will show you a little bit later as we proceed on, okay? So that's one thing you should always understand. Whenever you have your data sets, so make sure that you don't have as much missing data, all right? All right, now, another thing is you have to convert some data into numeric format, so they have to be processed. You see, when we described our data sets here, we only found that the columns with the numeric values, 1, 2, 3, 4, 5, 6, 7. So it means out of 12 columns, you have only 7 columns that have numeric values. So the rest of 5 columns doesn't have numeric values, okay? So which means in those columns, they have text information. Now, if there are variables that you need, they have to be converted from the columns, because the machine, in order for them to be processed by your machine learning model, they have to be converted into numbers, all right? Also, we have seen that some data are scattered. They have wide range between them. They need to be scaled, okay? Scaling means what? If I just come here real quick, I just show you something. Let's say in the age, you have 80 years, we have seen, then the minimum is 0.4. So the range is a little bit huge. This can be a little bit problematic when you're trying to, to build your models and try to make your models converge into high accuracy. So what you're going to do is creating a standard scaling. And by doing that, you can use what we call the standard scaler or the minimum maximum scaler, okay? They all work fine, depends on which one works best for you. But there can be other ways to go about that too, all right? Now, okay, so here we're checking the missing values. The missing values here, I'll just run this. What this do is, I just created a simple code that shows you the missing values and the percentage of the missing values. So for instance, again, I've shown this, how to find null values. So if you haven't seen this, please, I advise you kindly go back, watch in my previous videos, how you calculate missing values, okay? So the training data itself here, dot is null, because it's checking for all null values. Dot sum, it means it will find the total number of missing values in the training data, and then sort them in an ascending order, a descending order. and then find the percentage of the missing values, and then round off, find a very good accurate number, and then create. Here I'm creating some sort of a table here. It's a data frame. So, and in this data frame, it just shows something like this. So it will tell you that from these are the columns that with the missing values. All right, this is a very useful to me. I just take the whole data frame and find if there are missing values in there, it will create a table. So this table here is very, very informative because it tells me that, hey, in the cabin, you have in the cabin column, you have 600, more than 600 missing values or null values, which is 77% of our data sets. And the edge has 179 missing values, which is almost 20% of our data. In the back, you have two values, okay? Only two missing values, which is like 0.2%, which is very small. And the fair, because here I just printed 5, I could have done this for the rest of my data sets and then rerun this. It will tell me they're all my columns, okay? So you don't have any missing values here, which is fine. All right, okay. So now, oh, this is just, I was just wanted to show you. If you run this here, it will tell you this was before I put this one into a table. So just the first one, show you, I want to get an overview of my data sets, okay? So for now, this is okay. It's the repetition of the same thing. Now let's go to data visualization. Now this data visualization, this is where you draw graphs. And this is the very, very important part. I have covered on how to draw graphs using the Matplotlib in my previous video. So I would recommend you go watch the video on using the pandas data frame into visualization, all right? Now, in this case here, I have just created graphs that shows the percentage of survivors between men and women, okay? And the ages. Let me show you. Okay, I have a warning here. Okay, they say this plot, this is the deprecated function. And then I usually used to, I've been using this plot for quite some time, but now it's deprecated into this plot, all right? So I haven't worked with this plot yet. So I believe you can go and start working with it. I'll probably work with it in the coming videos. But for now, this draws me the graph, although it gives me warning, but I think it's a clear go. It doesn't care if the warning comes or not. I could choose to ignore this too, but I didn't. Okay, so sorry, my bad. So I recommend that in the future videos or when you're working out, to ignore this plot here, and then his plot I just use somewhere here. Yeah, it's not used. Okay, so this plot part, you can just ignore it. Now this plot says that you have a percentage of males and females. Well, if we try to observe the first one, it says, so for the percentage of the ones that survived and the ones that didn't survive, okay. So the ages from maybe 0, like few months, to almost 10 years here, you see the probability of survivors. Now, the ones that did not survive, let's see the female part and the male part. You understand? So it shows that the female part, they survived, which is a little bit, bluish. It has so this graphs, first of all, tells you that female had the highest percentage of survival, you see, than males, because in the male part, they survived. These blue lines are a little bit short here, around 15, that's the maximum. While when you come here, you see that you have so many survivors that are female, that's the first one, plus the kids, the young ages, okay? And then you see here, if I come roughly here, even for the female part, the highest survival probability comes from the age of probably 15 to maybe 30, something here. So from 20s and 30s, there are so many survivors. The same applies for age. For male, the probability of survival is higher for the teens, probably the kids, okay? Not just the teens, the kids, which is this one. So the bluish is higher here, plus you have a little bit here. But the highest death rate, the probability of not surviving, if for a male, it is lying here. You see, from the almost 20s, yeah, to probably 30. So this tells you that you have to have a variable called age groups. You have to classify them into age groups and see how they survived. Okay, there could be so many variables. So this tells you that the variables that also have, they participate in prediction or your survival rate is sex, because you have seen if you're a female, and then age, a female, mid-20s, you have a highest rate of surviving. And then the kids as well, because probably the female and the kids, probably they're put on priority with the lifeboats or anything, then the probability of surviving whether you're a male. So, okay, so you know that for now we need sex, we need age. Okay, now let's go to the feature engineering. So the feature engineering part, this is the most important part. The feature engineering part, this is where you decide which features to keep and which features to not keep, okay? What new variable you should add, what variables depend on what variables, what the correlation between variables and variables. So this is a very, very important part. That's it, because after we have already seen and analyzed our data, it's only then we can be in a good position to do better decisions for here. So feature engineering. Okay, so now the first thing is I'm going to drop the passenger ID simply because I don't think the ID of the passenger has anything to do with the probability of their survival, especially if the ID is just some random numbers, like from zeros to one, some numbers, like auto-generated numbers. I'm just going to take you back here in the passenger ID from zeros to the rest. Like these are just some random numbers. It does not have any significance in the survival rate of the passengers, okay, or survival chances of the passengers, okay? So if I run this here, it will drop the whole column. This column is called passenger ID column. Axis 1 says I'm dropping the column. I have already shown you how to drop values, dropping columns and dropping rows, deleting them. So if you have not actually mastered it or you have not seen it, I would recommend that you go back and watch my video about how to delete rows and columns in pandas data frames. Okay, so here I'm specifying that I'm dropping the passenger ID column, and by say axis equals to 1, it means I'm dropping the whole column. If I say axis equals to 0, it means I'm dropping the whole row. Okay, so run it, which is great. And the missing values. All right, so we are going to deal with the missing values. Now, the missing values, as you might know, at this particular moment, you have different kind of missing values. Lakini nimestop. Kanya baadaye. Wewe ingia fanya kazi. Wewe endelea kwanza. Nituenda wewe. Labda nusu saa. Unapause au? Nimepause. Unaweza kuendeleza. Ndio hapo. Nitaangalia napo sina kodi kwa naendelea. Sasa nitakuwa na kazi ya kufunga vipande. Bwana na rekodi sasa hivi. Sio kuanzia ameongea. Sasa hata nikitoa sino wanafunzi wanagonga hapo. Wewe unajua kwa hiyo bado nilipofikia. Ni submit hizi. Sasa nimekusanya. Unasaini? Hivi kama tumemuzia kama amepeleka. Wala kinaana.
muulizie, si kama unataka tunaomba huko ndio vitabu vya sasa. Picha pamoja. Fungua kwa gari ya. Ndani. Ala bora ndio kuna vile nini pale. Wale mbona sana wadogo. Hapo sasa mbona wako kuna. Sasa unaongea na. Uwezi bila aina nao nyingine lazima. Mbona? Yeye. Wewe ndio unataka kunitaka. Mbona? Ile ndugu. Ile ndugu kabisa. Kiongozi alikiingia hivi hapo anatoka. Tumbo kabisa. Hapo ndo unaweka ndugu. Kama ndio ndo mazao, hiyo ndo unaweza kuuza. Wewe unataka kunitaka kulipa nini? Sio kwa sababu tunasema. Sasa beba. Kama milioni ambayo ukimza utitiri basi. Au ni mjini. Sasa moja ni research hii. Basi wote wafanye.
So in order to deal with the missing values, there are different ways you can go about it, okay? So for instance, for the cabin part, because it has so many missing values, there are ways you can, for instance, you can decide to drop the column. Maybe if it has so many missing values, you see, you can decide to drop it. But then if you think that the cabin part can be a little bit decisive into predicting or into checking the probability of whether the person survived or not. So for instance, a cabin can be a section probably close to lifeboats, you see. So if you're dropping this, probably we're missing out on some very useful information. So for instance, people sitting next, to life jackets or lifeboats, sorry, it means they are probably in a good position to be rescued. Okay, so people sitting close to the rescue part, if we want to see how we are going to make this useful, the first thing will be to fill the missing values. And in order for us to fill the missing values, just check on how the cabin data is. So the cabin data, the way it looks here, okay, this is null. Let me probably display 10 values. I might see how the cabin looks like. Okay, here. Okay, here are the cabin values, like C85, like C123. You have maybe E46. So you have numbers and alphabets. So here we can separate the numbers and alphabets, and then we can try to convert it into numerical forms and then fill it with some numbers as well, so that it's not null anymore. Okay, so what we're going to do here is you have creating a dictionary here, just create a dictionary here and specify the numbers like the key A, 1, B, 2, 3, so the keys and the values. And in both of my training data and my testing data, you see, I'm going to check putting a for loop, an iterator that will go through all my data and then filling it. So you see, now a recompile, RE, this is a this is regular expression. So this regular expression means I'm searching and find a pattern. And then after finding a pattern, what I'm going to do is I'm going to fill a 0 for the ones that's not available and then convert the type into int. So at the end of the day, if you just check your data, it means now you have a meaningful section. So I'll see you the meaningful section that I have, but then the original cabin part, I don't need it, I'll remove it. So in my training data, I'm going to remove the cabin column, and in my test data, I'm going to do the same as well. So I've broken it down into numbers. For A, it will have its own numbers, for 2, for 3, and then fill all the null values with the zeros. Okay, so you can fill the null values with with what we call the mean, the mode, or the median. Okay, or you can fill with different set of numbers, of some random numbers. It depends on which one will make sense to you. Okay, and plus it depends on which one brings more accurate results in your model. So after running it, and then you go for edge missing values. So for edge missing values, I don't have so many missing values in the edge. I have 167, which is not very much. But here, what I'm going to do is I'm going to find the mean of the edges, and then I'm going to find the standard deviation of the edges, and I'm going to fill, the random numbers between the mean and the standard deviation. You see, so this random number function here, it is an NumPy function. So it is just create the random numbers from mean here. So it will take the random numbers from this mean here, which is here, to standard deviation. Just take any random numbers and then fill in there. Okay, so at the end of the day, and then convert them into type integer, and then because they are float, so all the floating part, I'll just convert them into type integers, and then the non-numerics that I'm going to put in numerics, I'm going to put them in type integers, and then everything will be fine. And the reason I'm doing this is because these are what we call categorical data. Now, categorical data is something very, very important. If you're going to understand, if you're going to work around machine learning, you have to understand the categorical data. The categorical data, I have this guy here and this website here that explains what categorical data is, okay, and how you handle categorical data. So categorical data, by its simplicity, this is just a data set that is it has category. It has probably a different set of categories. So for instance, in age, you have age groups, like probably a specific category of age, probably like kids, adults, young adults, you have adults, and maybe you have the old. So you have like different categories, which is a specific set of numbers. So these is an example of a category data. A sex, where you have a male or a female, you see? So it's also a categorical data, okay? Now, most of the time, these categorical data are actually in text form. So let me show you something here. If you're familiar with machine learning, you probably have encountered categorical features in many datasets. They include categories or levels. So they include different categories or levels that are associated with observation, which are non-numerical. Okay, that's say they're not numerical. They can be text, they're just anything but not numerical. Okay, and that's need to be converted into computer. So if they are non-numerical, the first thing you should do about categorical data is to convert them into numerals. So for instance, if you want to know a specific sex, the chance of survival for female or male, you cannot use a male or a female, but rather you have to convert that sex into a specific numbers and then use the numbers in your model. Okay, so they have to be encoded. And how do you encode it? It's it's not something I'll go beyond here, but this guy here explains some useful information on how to deal with categorical data. It's a data camp /tutorial /categorical data. Okay. Also, there is another guy here that explains something about categorical data. So if you want to find some further knowledge, just come here and read on how you can find categorical data. Okay, so let's go back to our programming part. All right. So another thing you are going to deal with is the embarked part, the port of embarkment. As you know, the port of embarkment, okay, I didn't run this one, sorry. Run the edge, or run the edge cell here. Okay. So after running it, after filling it, then this part here, I'm just printing the sum of null values in the edge column here, and it says 0. So it means I don't have any null values in my edge. Okay, the embarked, if you remember, we only had 2 missing values here. The embarked, like 881. So you had like 2 missing values, exactly 2 missing values. Now, again, here you can use any other, say the missing values, you can use what we call the mode, the median. You see, you can put some random values, whatever. But because it has just a few numbers, I decided to fill this with the most commonly appearing value. Oh, sorry. See, the most commonly appearing values. Now, the most commonly appearing values is S here, since the frequency is a little bit high. So I'm going to fill it with S, okay? So common value here is S, and then just use a for loop, iterating through your data in your testing data sets, your training and testing data sets, and then fill. I'm going to use this fill now method, but here instead of putting a 0 or a mean or anything, I'm going to put a common value, which is the value S here. So that should be solved. Again, if it's so much, you can also decide to drop, but the dropping, be careful when you're dropping it. Make sure that it does not have much significance in deciding whether or not a person in that particular column or information in that column can play a vital role in deciding whether or not a person surviving or not. In that case, is a survivor. Okay. Now we have to convert the features into proper formats. So some features has to be converted in proper. For example, a fair format, it is a float format, if you remember. So what I'm going to do is I'm going to just convert them into integers. If you have missing values, I'll put 0, and then the rest will be converted so into integers, okay? Using this S-type. S-type S-type means it transforms this column here into this type here. So the type is int or integer 64, okay? And then let me run this cell as well. Okay, that's great. Let's go further here. Now, so the other thing here, which is something I just learned from the from a guy in the cargo, they just explained this very well, and I thought I should acknowledge him, because what they did is he instructed that it's best to extract the titles from the names. This is something I didn't think of before. Now, after I just thought it makes sense, because what he says is it can be in a case that a person's name can play, a person's title or position can play a vital role in their survival. So for instance, Mr.'s, Mrs., Master, all these types, okay? So according to our data sets, you have these 5 sets here. You remember, I'm using this dictionary, you can see, because I want later on to take, to convert them into numbers, okay? So if a Mr. will stand for 1, Miss 2, Mrs. 3, Master, and so forth. So you have to make sure that you take all of them into considerations, okay? And you're going to replace. Again, I'm going to use the name extract, extracting all the strings here from the name, the title, and then check for the common ones, and then replace them with these guys here, and then put the numbers in there, and then fill the null values that you have, and then you display, see if you have any. So after that, you will drop the name. You have to drop the name, okay? Because you already, like we did in the cabin, after you have already created some features from the cabin, and then you don't need the original cabin column. We have already created some columns here from these titles. You don't need the name, so I'll drop the names. The reason you see I drop the names in both testing and training data here is because I've already broken down, extracted the titles from the names, and then put them into specific values. If there is a missing value, put a null. So here, if you can see here, I'm putting a null value if I don't have a title. So for instance, for some guys, I won't be able to find either of these names. So the new columns I'm creating, it will be some like obsolete, it will be null, it will be empty. So I don't want null values, that's why I'm putting a 0 here, okay? The same applied in the cabin part above, so I won't go back there. Okay, if I run, this will be fine. Just to show you how the name looks, I'll just come back here once again. So you see the name here, like for instance, this Mr. Owen. I'll take this title, so I'll have a new column. See, title column. I don't need this name, and this title we can contain whether 1 or 2 or 3. For example, this Mr. is a 1, Mrs. depends on how I specified here. Okay, so later on I'll just display the data sets so you see how they look like. And then it's easy for male and female. You only have male and female. So here, what I'm going to do is just break down the genders into male will be 0s and female will be 1, you see? And then I just map the genders. Here I'm not, okay, so you can see here I'm not dropping the original column simply because here I'm just converting them into 0s and 1s. I'm not creating additional columns, but here I was creating additional column title. There is a difference. I hope you understand this, okay? Okay, so for the ticket part, you remember the ticket part, okay. Let me see how the ticket looks like. This is the description of the ticket. Again, I don't think the ticket will contribute to some probability chances for an individual. That is my take, because we have as much information as we need. So we are going to just drop it. So I'll drop from the training data, and again, I'll drop it from the testing data here. All right. So just drop it, and then I'll create some feature categories here. The age groups. I've just made some sense with my own brain and say we have specific ages, like the first age group. So we have like 0 to 9. Let me just show you the age groups here for both training and data sets. Okay, so you have the guys below 11 years of age. You have the ones from 11 to 18, 18 to 22. You have 22 to 27. So just, this is very important. Create the age groups that will help you identify. And this made sense because, so I created these age groups here basing on this graph that I drew here before. If you just come back here, you see the ages here, like you have the highest survival from like around 11 or 10 years of age to 0 or to less. And then you have another category here, and then you have another category here. So there is no rule into how your age group should be like. Just create age groups depending on how you think your data sets is scattered. So for me, I believe it will be very great if I have these 7 age categories, simply because my data set is scattered in these ages, like the death and the survivors and the non-survivors. The number is well distributed in this age. So if to show you that, I just printed the value counts so that you see how many data according to how your data is distributed. Okay, so according to my data here, the 0 ages, like the 0 age group here, which is below 11 years of age, it has 68 values. Okay, and then the age group 1, it has 91 values. The age group 2, it has 111, and so forth until the age group 4, the age group 6, which has 167. So you can see I try to put some even distribution of my age groups. So if you see you have so many age groups lying in a specific age, so many, people lying in a specific age group, and then you have less number in a different age group, you might have outliers. So that is something I just wanted to avoid. That's why I broke down into these age categories. Okay, so it's like almost you have 90, you have 150, 100 roughly, give or take, for every age group. So the values according to my data sets, this is specifically fit. So for instance, in your data set, you might only have 5 age groups because you don't need as much age groups. And some people may need just further subdivision. The further you divide, the better, because it just gives you some idea of even distribution of your ages in all the groups. Okay, now, so we can create the category as well, because in the FAIR, you also have categories. As I told you, this is categorical data. Age is categorical data, so it's sex and FAIR. And for categorical data as well, I'm going to check. So the guys that paid below 700, probably pounds, they go to the first, which is the 0 category, okay? And then this is the same as this one here. So if you just go and take, it is the same thing. If you want to see, you can come here, you can display the value counts to both of them and see how they both, look like, okay? Let me run it. Okay. And then creating additional features. So there might be a case where you need some additional features. Again, this is another useful information. Shout out to my guy from the Cargo Dataset, the Cargo Forum. He also recommended that you should add creation of additional features. So the first thing he recommended was, I just showed you here. What was it again? What did he recommend? I think he recommended, okay, I can't find it. Oh, he recommended this one. So he recommended that you should, extract the titles from the guy, from the names, because they might add up into the chances of somebody's survival. And if you don't think this works, you can just put it aside. You cannot, it's not necessary that you should just do exactly what I did. You can decide to not use it, which is fine. And something else here is adding categories. Additional categories, you see? So this is something okay, at first I didn't use it, okay, but you might want to use it, because according to his science, he said there is a relationship between age and the class. Probably guys with a specific age, maybe they have prefer a specific class, probably, I don't know. So in this here, you just find the relationship, which is the multiplication, the product of age and the class, and then finding feature, which is called age class. Okay, again, this is totally how he approached it and the way he made sense to me, and I thought it is something I could just give it a try. And what you're going to do here is simple. You can create your model without these additional features, and then try to add additional features as well, and improve the results, see which one takes you where. Okay, yeah. But something you take here is you can add your additional features as well. And then you have the training data. Okay, so this is now my new data sets, my training data sets. This is the way it looks, at least. Now you can see we have added something here called age class. Here it comes, and the title here. You remember we dropped the name and put the title, right? We also added the deck. The deck, we just created this from the cabin, okay? So we have RAM numbers here. So for me, let me just print a little bit more. Let me display like 10 of these and then run. Okay, so for me, this looks very fine. First of all, I don't have any missing values. And then I have all the, I've converted the categorical features into numerical features. And then I've just put some good numbers in there. They look great. I don't see the wide range of scattering. Otherwise, if I will see, I will use a standard scalar. So for me, I don't think there is a need to use a standard scalar, at least as far as my data is concerned. And from now, it's now ready to, I'm now ready to put my data into my training data, into my models. Okay, so again, I would like to put an emphasis on what I just did. We have done data analysis, we have done feature engineering and pre-processing. Okay, now feature engineering is the most important part, but every part is very important, because if you don't do your data analysis well, if you don't analyze your data well, you won't be able to do good feature engineering. Okay, and if you don't, then when you analyze your data, there are some things you should just check: the information, the description of your data, draw the graphs, see the correlation between variables, see which variables can contribute high into the into target variables, and so that, and at the end of the day, have your categorical data, just convert your category data into some numerical data so that you can do some analysis very good. Okay, so that is a tip. Now, that's the first part of this video. Now, the second part is we are going to build our machine learning models. Okay, this is the part which is, it's also very important, but it depends on the previous part. If you feed the garbage to the model, it will just give you the garbage predictions. But if you feed good information on the model, it will give you good predictions. Okay. Now, the building machine learning models, the first thing you're going to do is you're going to select or to slice or to split your data. Into target variables. You see the decision variables. You see the dependent variables. So you have your training data, you have your testing data. Okay. So there are some different ways to do that. I even explained the train test split in my videos where I iris datasets with KNN. But here, I'm going to show you, okay, it's very simple. My training data here, this is my training data here. At this particular moment, this is my training data, okay? That's my training data, okay? Now,
Who is this? Ellie. Nilimwambia basi yule bwana mkuje. Ani ni waongo.
All right. So, I mean, your data sets here, your training, your data set has to be sliced into 4 different parts. The first part is called, first of all, the 2 parts is the training and the testing data. Okay. And then you have in the training and the testing data, and then you have the X and the Y. The Y is always the label. Simply, a Y is just, I mean, a Y is a vector, while, I mean, X is a matrix. So for instance here, the survive part, this can be a vector of space from like the first year to the last column, okay, the last row. And then the rest of these other variables, they create a matrix, okay? So what I'm going to do is, the first thing is I'm going to create my training data, my X training data, okay? So the training data, okay, here, I'll just say, I'll drop the survive part. I'll drop this guy here because I don't need it, okay? I don't need it because if I drop this, then I have the rest of the columns without the results, okay? And then the Y part, the Y part is going to be only this here, okay? Because these are the labels. So I'll put my model, when I'm putting my model, I'll say my model will have X and Y, while the X is anything but the labels, and the Y is the label only. I don't know if I'm making myself very clear, okay? Again, just to be very, precise, I'm going to fit my model with 2 information. The first one is the X and the Y. In my case, I'm calling them the X train and the Y train, okay? So the X train will be the portion of the data that does not have the answers or the survived. Like this guy here with all the information, like the class number 3, sex and male, age number 2, and so much information, but we don't know whether it survived or not as far as my training is concerned. And then I'll put the answers which are correspondingly the same, okay? I'll show you a little bit later. And then the X test, it will be the same thing, but in the testing data, okay? So I'm going to drop, okay? In my testing data, I don't need the passage ID. Remember, I already dropped the passage ID. All right. So I don't need the passage ID because it doesn't participate in the decisions. Okay. All right. So I'm calling the test data here. I'll make sure that the passage ID has been dropped. Okay. Yeah. Now I'm going to use my different models or different classifiers. Now, covering the classifiers is a very huge or broad topic because there are so many different classifiers, okay, or algorithms. Now, as far as this class is concerned, I'll just use a few, classifiers. Okay, I'm going to use decision tree. I'm going to use stochastic gradient descent. I'm going to use random forest. I'm going to use K-NN. I'm going to use linear SVM. I'm going to use perceptron. I'm going to use logistic regression. I'm going to use Gaussian Bayes. Now, it's very easy. If you understand how you can train the model, because here I'm going to train in my models. Okay, so here I'm building, or here I'm going to train my model. So the first thing you're going to do is make sure that you have imported the necessary file. So let me run this first. Okay, so here make sure that the first thing you have done is you have imported the necessary files. Okay. So the necessary classifier, like decision tree classifier, has already been included somewhere there. If you just come up here, you'll see the decision tree classifier is somewhere here. So it comes from the scikit-learn.tree, you see, import decision tree classifier. And this goes for the rest. You have to know like where exactly they come from. Okay, that's great. So now let's just go back here and say, okay, so I'm going to put a decision tree classifier. In here, there are some things that we call parameters. I haven't included some. So for some, you see some parameters, for some, there are no parameters. But these parameters, it is something that you should work on because as you put on as good parameters and do the hyper-tuning parameters, that's where you have chances of scoring higher in your metrics. It can be secure, it can be classification, it can be, accuracy, precision, recall, F-score, and so forth. Okay. So the first thing here is I'm going to say, okay, hey, decision tree, I'm going to use you as decision tree now. So this variable here, I'm going to use it as we proceed, referring to the decision tree. Okay, so I just like to call this reference variable, okay, or object. Now, there is what we call the fit method. The fit method is the method that takes the X train and the Y train. You remember that? We just split this. So the X train, these are all the features that do not have the target variable. Remember here, we drop the target variable. And the target variable, it is contained in a Y train, okay? So if it's contained in a Y train, it means what I'm going to do here, I'm saying, hey, model, I'm giving you the X train and the labels. I'm giving the features and their labels, okay? So I want you to train. So they have been training. So this specific line here trains your model. And then the following lines does what we call the prediction. It is going to predict, okay, by calling the predict method. And what is predicting? It is predicting from the X test. Remember the X test here. The X test here comes from what we call, it comes from this guy here. The X test here comes from this guy here. The test file. Remember the test data file? Okay. So here I'm doing my prediction on my test file. Okay. Now it's a little bit tricky. I'll explain a little bit later, simply because I don't have, I don't have what we call, I don't have labels in my testing data. So it will be very hard for me to see how I score exactly on my testing data. Okay. And then in this step here, I'm going to put the model, this step here, this step here. This is just a variable I'm creating. And then it says, hey, decision tree, I want you to check the score, which is the accuracy of train, and then against the X train and against the Y train times 100. Okay. So if you just get the score, this will give you, accuracy, because this will just take these guys and times the percentage, and there's a round function here. It just rounds off these two 2 decimal places, okay, and just create a score for this, all right? And then the same, I'll do the same for another model called, SHD classifier, which is, stochastic gradient descent. You see, it has 5 maximum iterations. And then I'm going to do the same for random forest. It has 100 number of estimators. And then I'm going to do the same for k nearest neighbors. I said, hey, neighbors only should be 3. If you don't specify the neighbors, remember, if you don't specify anything in here, they will be just created by default. So for instance here, I know the tree classifier has what we call the maximum depth, like the depth, because it's a tree, right? So it has a depth. It has to be a specific depth. Okay, so if you don't, they put something, the default for you, okay? I know the default number of neighbors for KNN is 5. So if you don't specify, you say 5 neighbors, okay? So I'll do for linear SVM. I'll do for perceptron. You can also have MLP, multi-layer perceptron model, logistic regression model, the Gaussian night base. So these are just values. You can see here, I did not put, so much parameters in here, because that's your job now to go and put on parameters, but at least you know how to train every model at its simplicity. You see, at a very simple stage, you should be able to create your model. First of all, how do you create your model? Import the necessary library where you know the model is coming from, and then call the model, assign it to a specific object, then use the fit method to put in your data, fitting the X train and the Y train, or the X and the Ys, and then do the prediction, okay? And then after that, check the score. You see the score here. Now checking the score, the scores that I'm checking here, I'm using, the score here. This is very shallow, okay? Now in the next videos, I'm going to show you, I'll concentrate on hyper-tuning parameters, like putting more parameters into your model, and then use different values for checking the scores, because here you have so many different values inside. So I'll put in different values, and then you see, like checking the recall, the precision, you see, yeah. So for now, at this particular instance, this is how you work on. Again, I did not use the prediction part because, I'll not use the testing set in my prediction simply because I cannot have the score. So if it was meant for these values to be submitted into the Kaggle dataset, but because I'm just showing here for the training purpose, this is just for you to understand how to go about your, creating your first model, which is a classification model. This is a detailed, full information about how to create your dataset. So I believe at least from here, you'll have an insight on how to go about your machine learning model projects as far as classification is concerned. Okay, now this is the part where I need to select the models. So what I like to do is, this approach is I just put different models, like you can put 10, 20 models, and then select what's the best model, like the model with the best accuracy or the best score. So here, I'm going to create a pandas data frame called results. I've shown this 100 times, million times in my previous videos. If you haven't watched, please kindly advise that you go back and watch. And then here, so here I'll take the models, and then I'll take their scores here. So for instance, this linear SVC is a score from linear SVC. Everyone is a score from a different model. So all of these models, because they contain the score. Okay, these are the names of the models and the scores they contain. So the next thing you should do here, oh my God, I think I have a little problem here, but don't pay attention to this. So I'll sort the results. If I come here, I say the results, hey, I want you to sort the results by the score. So the results will be sorted by this score here, okay, in an ascending order. No, sorry, I think I have a problem somewhere. Yeah, they should be, they should be in an order. Support vector machines here should be this one, support vector machines. Kenyan should be Kenyan. Then you have logistic regression. Yeah, logistic regression here, number 3. You have random forest. I have number, okay, it's an order. Sorry. I thought I was just, I overlooked this. I thought it was a little bit wrong. So here, what I'm saying is I'm trying to match the columns here I'm creating, because here I'm going to create a little table that does that. Okay. So I'm just matching because these guys here contain the values, but these here, these are the columns. Okay. Now, after that, I'll set index, then I'll sort them in the scores, and then I'll display the first 9. Oh, sorry. SPC is not correct. Oh, I did not run these guys. Sorry. I'll have to run these, run them, run all of them. Okay, so I've run all of this. Now I come here. If I run this, should give me results. Okay, so you see here, I have a very beautiful table here that says, hey, these are your scores because you have sorted them here in a descending order, because I said ascending false. So it means I'm setting them in a descending order. I say the first model is random forest. So random forest model here has 92.82. Remember that I used a round function here. Remember this round function I use in every model here? So this round function here will round off your answers into 2 decimal places, okay? So if I don't specify this, it will just take me to a very huge precision, which is okay. It will take me to some like 4, 5, 6, 7 decimal places. I don't remember the exact numbers, which is good because in some places, it's very easy for these guys to be closely related to each other. Like for instance here, random forest and the same tree, they have like almost the same thing, right? But if I just go to further division, the precision will just be a little bit different as the decimal places goes a little bit further, okay? So this shows you now the results of your model. Again, these are the results of my model depending on the score that I just put there, which is an accurate score. But all I want from you now is to make sure that what I haven't covered here is how to evaluate using different other scores like precision, recall, F1 score and others. So I'll definitely put a video in the future that will cover that part. It may not be used in the same Titanic datasets. I'll probably use the different project, but then I will make sure that that part will cover, how to use different other metrics and what are they actually and what they mean. But in this video, I have shown a detailed information on how you can go about your data sets, reading them, analyzing them, drawing visual graphs so you can have a deep understanding. We call them exploratory data analysis. And then you do feature engineering where you fill the missing values, you add values, you delete values, you just put additional features, understanding which features works best, and then train your models, then find results, and then putting results in a good display format like that. So thank you for watching this video. Now, please be attentive as we're proceeding with beautiful content as far as YES Lab is concerned. Now, stay safe, guys. Thank you for watching.